Hello and good day everyone. We are from Group 7. The mission that we choose for the Ericsson Tech Traveler Games is Mission 3. Therefore, we will be presenting the topics under Mission 3 which are pulse modulation, multiplexing, impacts of the techniques to the society, and followed by the misconception on the topics. In early 1990s, telecommunication is transforming towards digital world. Transmission line and switching has been using digital signal in their operation aligned with the rapid advancement in VLSI and microprocessor fields. Therefore, information signals must undergo digital sampling in order to transmit through this network. Before entering the topic pulse modulation, let me introduce the fundamental principles and techniques that use for conversion of signal from analog to digital in pulse modulation. Firstly, frequency range. Frequency range can be detected by human ear are from around 20 Hz to 20 kHz, while in telecommunications, voice band frequency is normally set from around 300 Hz to 3.4 kHz. This is because only reasonable digital reproduction of voice needed to be encoded during the conversion from analog to digital to save the bandwidth. Next, sample rate and sampling theorem. Sample rate is the number of samples measured per second with unit in Hertz, while sampling theorem defines the relationship between sample rate and frequency bandwidth. To perform a proper sampling, Nyquist or Shannon theorem is established, which the sample rate needs to be at least twice the maximum frequency bandwidth. For example, a voice signal with frequency bandwidth of 20 kHz needs a sample rate of at least 40 kHz to ensure accurate digital reproduction. Apart from that, bit rate and bit depth. Bit rate is the number of bit transfer per second, while bit depth is the number of bits of information in the sample, or also known as resolution of each sample. For information, higher bit depth can result in more accurate readings. Other than that, quantization. Quantization is the process of encoding a sample from analog to digital by estimating the amplitude of the sample into a suitable value for encoding. However, quantization noise or error will be exist when there is a difference between the sample value and quantized value. After that, let us talk about the pulse modulation. Pulse modulation is a type of modulation where the carrier waves are pulsed and the parameters are modulated to carry information. Basically, there are four types of pulse modulation, which are pulse amplitude modulation, PAM, pulse width modulation, PWM, pulse position modulation, PPM, and pulse code modulation, PCM. For PAM, PWM, and BPM, the amplitude, width, and pulse delay is proportional to the amplitude of the modulating information signal respectively, depends on the type. While for PCM, it is a form of signal modulation where analog signal is represented by digital code. In other words, PCM can be defined as the modulation method that transmits the pulse in the form of binary digit representing a code number. In general, process of encoding sample signals through PCM constitutes of three processes, which are sampling, quantizing, and encoding. Therefore, the first step is sampling the analog signal, followed by quantizations of amplitude of the sample signal, and the last step is encoding the quantized sample into digital signal.
Multiplexing is an important technique in telecommunication system as it is impossible to transmit one signal using one transmission channel. With multiplexing, two or more signals can be transmitted over a single channel at the same time. After the transmission, the combined signal will be demultiplexed to original signals. Hence, a dense number of data can be transmitted in one communication channel and cause the increment of the capacity. There is three multiplexing methods, whereas frequency division multiplexing, time division multiplexing, and space division multiplexing. Here come with our first multiplexing method today, which is frequency division multiplexing, FDM. FDM divides the frequency spectrum of higher bandwidth to smaller bandwidth. FDM can be used in both analog and digital systems. It uses different carrier frequency to each signal inputs so that no overlapping after multiplexing. Next, wavelength division multiplexing (WDM). This multiplexing also same as FDM, which use different carrier frequency, but the difference is the frequency used in WDM is up to gigahertz, and WDM use different wavelength of light to transmit. Hence, WDM use optical medium as transmission channel. Another common multiplexing method is time division multiplexing (TDM). Unlike FDM and WDM, it used in digital system only, and same carrier frequency is used. TDM divide the input signals by time slots. In TDM, it can be divided into PAM and PCM, or synchronous and asynchronous. Lastly, multiplexing is important as it helps us to reduce the cost and time, where multiple signals are transmitted in one channel at the same time. Besides, it easier cable management as the number of cable reduced. Furthermore, multiplexing utilizes the use of medium bandwidth in our daily life.
Hello everyone, here is DICKSON and here we will introduce about the impact and benefit of digital communication in society. So some of the impact and benefits include increase of communication capacity, and in terms of communication capacity, both PCM and multiplexing have made it possible to transmit multiple signals over a single communication channel, hence increasing the capacity of communication system and more signal could be transmitted at the same time. Besides, PCM helps to improve the quality of the signal communication. PCM has allowed for the digital representation of analog signal, and it will resulting in improved signal quality and reduced noise, as digital signal are less sensitive to noise compared to analog signal. Next, multiplexing help in increasing the efficiency in signal communication, as multiplexing enables the sharing of resources such as the communication channel, and resulting in more efficient use of communication infrastructure. Finally, PCM and multiplexing have made it possible to transmit data and voice signal over long distance with lower cost, as compared to traditional analog communication system. And this in turn helps to reduce the cost of the communication device, such as telephone costs, and make it more affordable for most people in the world. In overall, these all have contributed to the growth of industries such as telecommunication, broadcasting, and data communication. PCM and multiplexing have also played a critical role in enabling the development of modern communication technology, including the advancement of internet, and it will have higher advantages compared to analog communication. Next, we will be talking about the misconception of digital communication on various aspects. There will always be some misconception about the advanced technology by the community, and this also applies to digital communication. In terms of health, some people may believe that the electromagnetic field EMF emitted by the communication device can cause harm to the body, while EMF is actually a natural part of our environment, and all of the EMF level emitted by communication device are generally checked, and it is also ensured within the international safety standard, and it will not affect the human body. While in terms of safety, some might believe that PCM and multiplexing can cause fire, but PCM and multiplexing systems do not typically cause fire. If a fire occurs, it is usually due to the failure in a different component of the system instead of PCM or multiplexing technology itself. Other than that, intellectual property. So some individuals might mistakenly believe that PCM and multiplexing technology are protected by intellectual property laws, such as the copyright. While some aspects of this technology might be protected by the laws, but the underlying principles are often considered to be in the public domain. Meanwhile, for the cultural aspect, some individuals might believe that PCM and multiplexing technology are causing the displacement of traditional cultural practice, such as face-to-face communication, storytelling, and music making. While this technology may change the way in which cultural practices are performed, they can also provide new opportunity for cultural expression and exchange. Hence, the traditional will not be forgotten just due to the technology's reason. That's all for this section. Thank you.